8.3, using the unittestmock package. We're going to look at what a mock object is and what it's for, how to make them, how to check whether they were used properly, and how to replace existing objects with mock objects. We've talked about how it's important that unit tests only interact with a small section of code. But how can we arrange for that when so many pieces of code interact with objects and functions originating all over the source tree or throughout the standard library? One answer is that we replace those objects and functions with mock objects. A mock object is a clever piece of code. It can pretend to be almost any kind of object or function, but instead of doing whatever the original did, it just records what is done with it so that we can check it later. Let's play with a mock object for a moment to begin to get a feel for them. We can access pretty much any attribute of a mock object without defining it ahead of time. The result is another mock object. Similarly, we can call almost any method we want without defining it ahead of time, and the result is yet another mock object. In this example currently on the screen, the only attribute we access or method that we've involved that is actually part of what it is to be a mock rather than just the mock pretending to be whatever it is that I'm imagining it is the method calls attribute there, which is a list of the method calls that I performed on the mock and its sub-objects. That by itself is enough to let a mock object replace a large range of the functions and objects that our tested code might interact with. We can go even further if we take the time to pre-configure our mock object. We can assign non-mock objects to a mock object's attributes so that accessing the attribute provides a specific value instead of a generic mock object. We can also assign a customized mock object in place of a method so that we can make the mocked method act more like the original, but in a way that's controlled by the test. We do that by passing a return value parameter to the mock constructor, which tells the mock object that every time it's called, as if it were a function, it should return that value. If we want the mock to return different values each time it's called, we use a different parameter of the constructor, called sideEffect. We have to know how many times the test will call the mock as a function, so we can provide a return value for each call, but otherwise this doesn't present a difficulty. We can also make the mock object raise an exception by passing that exception as the sideEffect or as a member of the sideEffect sequence. That pretty well covers how to make a mock that can, in a controlled way, stand in for real objects in code while we run our test. However, to really support testing, we also need to be able to check the mock to see if it was used as expected. We've already seen the method calls attribute of the mock objects. We've already seen that method calls attribute that the mock objects use to track their interactions. But mock objects also have their own assert methods that are usually easier to use than accessing the method calls list directly. The most useful of the mock object assertion methods are assert called with, which checks whether the most recent call to the mock object was done with the specified arguments, and assert any call, which checks whether the mock has ever been called with the specified arguments. So we know what mock objects are for, how to create them, and how to check their record of what was done with them. That's enough for replacing the parameters of a tested function with mock objects. We can even replace the self parameter of methods. We can even replace the self parameter of methods if we call the method via the class instead of a real instance. What do we do, though, when the code we're testing reaches out into the system on its own and accesses something we'd rather replace with a mock object? For example, what if the code we're testing calls time.time? That's where unittestmock's patch function comes into play. Patch is a context manager, and it can temporarily replace very nearly any object in any package or module with a mock object. Once the block exits, the real object is restored to its position. Something to be aware of is that patch doesn't replace every reference to the target object with a mock. It only replaces the single reference that we specify in the first argument of the patch call. In our example, any code that accesses the time function by looking at references in the time module will get our mock object. But if there was any code that had used from time import time to create a local reference to the time function, that reference would still refer to the real time function. If we want to patch the time function for code that has a local reference to it, we need to pass the path to that local reference into patch. Instead of patching it in time.time, patch it in example.time or local.time or whatever the current module is, or the module that has the local reference. We're pretty much good to go with mock objects now. That means we know everything we need to write powerful tests easily. So a mock object is a stand-in for another object. They help us keep tests from interfering with each other or from spreading out into the code that they are not supposed to be testing. Mock objects record what was done to them, so we can check it later as part of our testing. And unittest.mock.patch can temporarily replace another object with a mock object. All we have left to do is to find out how to run our test suites, which is the topic of the next video.